Okay, the following is a video about the Fundamental Theorem of Calculus, Part 1. This is probably one of the more important things that we'll cover this year, but I want to go over this worksheet that I gave you guys in class, just so that you guys know what's going on. I'll let you guys kind of read through this, but I'm gonna apply this idea of the fundamental theorem to the problem that we've been using all year with the position, velocity, and acceleration. And so the first thing I want to do is introduce to you something that's completely brand new. And it is called an integral function, okay? There's a this writing up here explains what this is, but basically I have a function that is an integral. Now, if you notice here, I have this negative 9.8t plus 19.6 dt. That is my velocity function, okay? Now, remember, if I integrate my velocity, v of t dt, then it gives me my position. It gives me p of t, all right? So, this is in terms of my position is a function in terms of x. My position is big F of x. My velocity we'll call little f of x. Now, the one thing that's a little interesting here is that I'm using two different variables. My x value is the upper bound of my integral, which is different, okay? So I'll kind of show you what that means here in a second. But basically, I'm using this function, this idea, but I have to use a different variable t than what I'm doing up here for x, okay? So just kind of keep that in mind. I know it's a little confusing. It's kind of hard to see, but just bear with me. But what we're going to do here, we're going to need your calculators to do this. We're going to find all of these different function values for big F. Okay, so the thing that I want you to see here is that if I were to evaluate big F of 0, then that looks like this. Big F of 0 is equal to the integral from 0. Now, guys, remember, I'm plugging in 0 for x, okay? And so that value is going to go as my upper bound up here. So I go the integral from 0 to 0 of negative 9.8t plus 19.6 dt. And when I do that, what's the area under my velocity function between 0 and 0? Okay, what's the area over that interval between 0 and 0? And what you come to find out is that that area is 0, okay? And let's just go to our calculator and evaluate that. What I'm going to do here, guys, is I'm going to actually do this via the graph. And I'm going to graph negative 9.8x plus 19.6, okay? And if I graph that on the standard window, let me change my window to 0 for negative 20 and positive 20. Okay. So now if I graph this, same graph that I get down here, and I'm going to integrate between 0 and 0. All right, just so you can do it. So second, calculate 7 for integration. We're going to start at 0, and we're going to end at 0, and then we get an area of 0. So because of that, all right, that's why we get that. Now, here's what I'm going to do. And here is the big thing. Now that I've calculated the area under that curve between 0 and 0, I'm going to come up to my velocity function, and I'm going to plot that point here. So my position at time 0, when that object is first launched from the ground, has a height of 0. Okay? So now what I'm going to do is I'm going to find f of 1. Okay? So I'm going to come in here and I'm going to find big F of 1. And what I'm doing here is I'm finding the area under the curve between 0 and 1. So 1 is the upper bound of my integral now. Okay, that's my input into this function. And I'm going to calculate the area under the curve. Plus 19.6 dt. All right, so let's go to our calculator. Let's figure that out. So let's do second, calculate 7 for integration. And so we went from 0 to 1, okay? And so if I accumulate the area under this curve, I get 14.7. So that area, this value here is 14.7. Okay, now I'm going to plot that point on my position function. So it's somewhere up here. I think this is around 10, 15, put it up here somewhere. Okay, and so that was that area under the curve between 0 and 1. That area was 14.7. So now I plotted that point up here. Okay, now let's do big F of 2, and let's see what we get for that. So big F of 2 means that we're going to calculate the area under the curve between 0 and 2 of negative 9.8 t plus 19.6 dt. Okay, so if I do that, let's go to our calculator, and let's do, let's go to second, calculate. 7 for integration. We want to integrate between 0 and 2. So we get all that accumulated area between 0 and 2. We end up getting 19.6, okay? So we get this value for 19.6. So if I continue to accumulate all of this area, I'm going to get 19.6. So, and what I have there, and hopefully what you're seeing here, is we're kind of getting a parabola, all right? So now let's go back. Let's do f of 3. All right, and f of 3, you should kind of already know what we're going to get there, but that's the integral between 0 and 3 of negative 9.8 t plus 19.6 dt. All right, if we go to our calculator and I integrate between 0 and 3, so lower bound of 0, upper bound of 3, and it's going to continue all the way over on this side too. And we end up getting 4.7 again. So remember, this area here and this area here kind of cancel each other out. They add 0 because this is negative and this is positive. So we end up getting a value of 14.7. Okay? And so we get this point right here. All right? And so now the big question is, all right, well now what's f of 4? What's big F of 4? So big F of 4 is going to be the integral between 0 and 4 of negative 9.8 t plus 19.6 dt. Okay, if I find all the area, all this accumulated area under here, this area, and then this area, I should get 0. Okay, now let's just double check on the calculator, and let's just make sure we get that. But let's just go ahead and integrate between... Second, calculate 7. So we want to go from 0 to 4. So if we accumulate all that area, this area and this area are on opposite sides of the x-axis. They have the same area. And so we get an area of 0. Okay, and so, but that, it's kind of interesting to get that, to get these values, because what we end up getting here, after we've plotted those points, we can answer this question in part 3, what does the graph of big F of x look like? And it looks like a parabola. Okay? And so we can kind of connect those points. Hopefully you're better at curve sketching than I am. All right? But you end up getting a parabola. You get the idea. Okay? And then you say, okay, well now can we write the function for big F of x? Well, guys, we've done this problem before. Okay, and so, you know, really, we know that this position function is just the antiderivative of this. So we know that big F of x is really just going to be negative 4.9 t squared plus 19.6 t. Okay, and, you know, there really isn't, you know, you could put the plus c here, but we kind of already know a point on the value. What's our initial condition? At time 0, you know, remember big F of 0, that was equal to 0. Okay, and so then we know based off of that that c is equal to 0. So we're kind of disregarding the c a little bit, but that's the gist of what we're doing here. Okay, so but here's the thing, guys. I have my function for big f of x. Oh, and this should be an x, not t. I'm sorry. This should be an x. Okay. But the reality is that this function and this function here are the same. Okay, and that's something that's brand new to you. That's something that you haven't really seen before, but these two different functions are the same. Okay, I'm going to stop this video for time purposes, and I will make another one for the rest of the worksheet.